Okay, so I did publish these on the module if you need to look at them later, but these are the solutions for P2 Part B, which was the negative exponents, okay, and the rational exponents, which were the fractional exponents. So 1, you wanted to simplify, right, cross out, so 8 minus 6 is 2, and then 4 squared 16. 2, you're going to simplify, cross out 8 of them, and that's 4, so it would be x to the 4th. 3, the negative goes to the top, so it would be 6 to the 4th and then 6 to the 3rd. Add those together, you get 6 to the 7th. If you wanted to leave them as they are and subtract them, which you can do, remember you always do the bigger exponent minus the smaller. So it's 4 minus a negative 3, and that becomes 4 plus 3, which is 7. And you would leave it where the bigger one was, which is in the top. So you can also do it that way. You can either move the negative and then simplify, or you can subtract the exponents. Just be careful, make sure when you're doing that minus a negative that you change the sign. 4, you're going to simplify the 4 and the 6, and then you want to flip-flop the r's and then simplify from there. Yep.
Can I go to Ms. Pulaski's room real quick? She needs to see me.
Sure.
Thank you.
Take the pass. 5 would be 4 n to the 7th over 3 m to the 7th, and 6 and negative 4 r to the 6th. Questions on any of those questions from this page? Kiara.
For number 4, would it be the same thing if you did 2r cubed over 3?
Yes, like you kept r cubed in the top? Yeah, totally fine.
Okay.
Yep. Any other questions from that page before we get to the next one? All right, this is 7, so it would be 625 over a to the 10th. 8 p to the 4th over 5. 9, 1 over 2 pq. 10, 4 over a squared. 11 gets into the fractional exponents. So remember, 1/2 is the same thing as the square root. That's 13. And 4th root of 16 is 2. When you break down that 16, there are 4 2's there. Questions on this page? You're welcome. All right, 13, negative 4/3. 14, because, oh, sorry, go ahead, Gianna. Sure, just sign out. Just remember, we're going to miss these questions, so I hope you're good. Okay, so 14, or 4, would have been negative inside the parentheses. The brackets are the same thing, right? And then we're square rooting this. So that negative gets kept underneath the square root, which is why this is no solution. You cannot square root a negative number. If it was just negative 4 to the 1/2, now it's negative square root 4, which would be negative 2. That one's okay. The parentheses is what says keep it with it underneath the square root, and that's what you can't do. 15 is 4. 16 is 1,000. 17 is negative 27. 18 is 256 over 81. And 19 is 9. All right, so 17, first of all, the negative is not in parentheses. So that means it's going to get bumped to the front of whatever it is, right? So this is negative and then 81 to the 3/4. So then the 4 slides over to become the index. So now I've got negative 4th root of 81 raised to the 3rd power. So bottom slides over, top becomes the exponent. So then 81, you can break it down to like 9 and 9, which is 3 and 3 and 3 and 3. So there's 4 3s, which means one's going to come to the outside. I still have negative. It would be 3 to the third, and then 3 to the third. 3 times 3 times 3 is 27, but then it's negative. So it's negative 27. So just be really careful. The negative's what's tricky there, right? Other questions from this page? Okay, 20. So same base. We want to subtract the exponents. 5 thirds minus 4 thirds is 1 third. 64 to the 1 third is 4. 21, the negative k exponent in the bottom, you can bump to the top, or you could have combined them in the bottom and then moved it. So how you do that's up to you.
Can you explain that one, please?
Yeah, so did you get rid of the negative by moving it first, or did you combine the denominator first?
I moved it.
Okay, so if you move it, this is going to go to the top, right? So I get k to the, which is probably what I would have done, k to the 1 third and k to the first over k to the 2 thirds. Right? Now you've got 2 in the top. I want to combine them together, so I'm going to add those exponents.
Okay.
So I get k to the 1 plus 1 third, or 3 thirds plus 1 third, which means k to the 4 thirds, over k to the 2 thirds. Then you've got 1 in the top and 1 in the bottom, same base. So I want to subtract them. 4 thirds is bigger than 2 thirds, so k to the 4 thirds minus 2 thirds is k to the 2 thirds.
And then
Danielle.
you-
Oh, sorry. Go ahead.
Sorry.
You can leave it like that.
Okay.
Yep. Go ahead, Danielle.
Is that okay to rewrite
You're welcome.
the radical?
Sure. Like you wrote it as the cube root of k to the second. Yeah, same thing. It would only be if it told you to leave it exponential, you want to leave it exponential, or if it told you to put it in radical, then you want that kind of answer. All right, 22, I would have distributed the exponents first. That gives me x to the 4 thirds in the top and x to the 14 thirds in the bottom. 14 thirds is bigger than 4 thirds, so we subtract. You could have left this as, from here, you could have done 1 over x to the 10 thirds by subtracting it and keeping it in the bottom. Or, like this is Miss Ferrier's work, she subtracted it and then it was negative, so she moved it to the bottom. You kind of have that choice. Either subtract it, keep it where it's bigger, or subtract it, and then if it's negative, move it. Good on that one? Yeah. Okay, 23, you had to distribute. I'll zoom out on it, there it goes. You had to distribute the 1/4 to each term inside. So the 16 gets the 1/4, the m to the third gets the 1/4, and the n gets the 1/4. And then distribute the 1/2 to the 9, to the n, and to the m. Excuse me. And then you want to simplify. So the 4th root of 16 is 2. The square root of 9 is 3. And then combine all of your variables. So you had an m and n in the top and in the bottom. You want to subtract and leave it where it was bigger. Yep. Can you put it in radical form? So I would say you don't want to leave the radical in the denominator. It's not that it's wrong, but you'd have to rationalize, which makes it yucky. So it's better to keep it in exponential form, but I don't know if I'd mark it wrong. Yeah. The last part being what, Lucia?
How do you go from 6 and 3/4?
So this step to this step?
Yeah.
Yeah, okay, so 6. Okay, so tell me what you would have done. Would you have moved the negative or would you have subtracted?
Probably would have moved it.
Move the negative. So this one's going to go down to the bottom, right? So then I have m to the 3/4 in the top, m to the first in the bottom. So the 1 is bigger than the 3/4. So I want to do 1 minus 3/4 That becomes 4/4 minus 3/4, which is 1/4. And it goes where it's bigger. So the 6 is going to stay in the top, but the m to the 1/4 is going to go to the bottom. So I had m to the 3/4 up here, and I had m to the 1 in the bottom, right? And 1's bigger than 3/4, so it stays in the bottom. Then you've got both ends in the bottom, n to the 1/4 and n to the 1/2. So we want to add those. So 1/4 plus 1/2, or 2/4, becomes 3/4. So I got 6 in my numerator, m to the 1/4 and n to the 3/4 in the denominator.
Thank you.
You're welcome. Any other questions from this page? All right, then P2C, which was your square root. So you want to get that one open. All right, so 1, I would have split that square root. You should have gotten the square root of 9 over the square root of 25, which is 3/5. 2 cannot be combined because they are not the same square root, right? So 1's 6, 1's 10. Neither can be simplified, so it gets kept exactly as it is. 3, you want to FOIL that out. Root 5 times root 5 is 5. Root 5 times negative root 2 was a negative root 10. And then root 2 times root 5 is a positive root 10. Positive 2 and negative 2 cancel out, and you're just left with 3.
For number 2, why wouldn't you bring out the 2 and the 5?
So there's neither of them have a pair. You can only bring them out if they repeat.
Okay.
Yep, so if they don't repeat, they stay.
So if it was like 2 and 6, then you could do 3 and 2?
Correct.
Okay.
Yep, then you could bring that out.
Thank you.
You're welcome. 4, be very careful there. Remember, like, that does not mean distribute my squared power. That means take this parentheses and duplicate it and then FOIL it out. You should have gotten 3 minus 2 root 2. 5, you're FOILing again. You should get 58 plus 5 root 5. And then 6 begins the rationalization. So you have to multiply both the top and the bottom by the opposite of the bottom. So square root 5 minus square root 3. Yep.
For 6, why can't you just cross out the...
So think about like your rules of simplifying with variables. If I had something like this, can I cancel this? You can't. If it's multiplication, you can. If it's x over 3x, you can. But if it's addition or subtraction, it's like protected. You can't cross it out unless you can cross out the exact same. So if it was x plus 3 in the top, x plus 3 in the bottom, now I can cancel it out. But you can't cancel out part of a sum or difference, which is the same rule for square roots. I can't cancel out because this is like a little protected partnership. I can't cancel just part of it. Unless it was a square, unless it was multiplication. So if it was square root 3 times square root 5, then I can cross them out. But if it's an addition or a subtraction there, you can't. In the numerator or the denominator. Okay. 4. So this, I'm going to duplicate. I'm going to rewrite square root 2 minus 1 times square root 2 minus 1. That's what squared means, right? I can't distribute if it's a sum or difference. So then I just want to FOIL it out. So I'm going to multiply square root 2 times square root 2, which is just 2. Square root 2 times negative 1 is negative root 2. Negative 1 times square root 2 is also negative root 2. Negative 1 times negative 1 is positive 1. Then I've got 2 square root 2's, right? So it's negative 1 and a negative 1, which would be negative 2 root 2, and then 2 plus 1, which is 3. You're welcome. Any other questions from this page? All right, now we just get into the factor tree, right? Factoring it out and then simplifying. So 7 should have been 2 root 30, 8, 30 root 2, 9, 10, And that says the absolute value of z, which happens if you're going to square root a variable. It's got to be positive. You're going to break down the 32. It becomes 4 root 2. And then there are 4 b's underneath, so you can take out 2 of them. 11, 5r, square root 3r. 12 is 30. 13 is 6. And 14 is 9. Isabel.
For 9, does it have to be 10 absolute values C or just, or 10 C?
For 9, it should be absolute value of z. I don't know. You just want to get in the habit of if it's an even power, when you bring it to the outside, you make it absolute. I don't know if credit would take, that's a question I have to talk about with Miss Ferrier and Miss Corey, so we're all on the same page, if we take the credit off of that or not. But if it's an even exponent, right, not odd, it doesn't matter, because it could be negative, it could be positive. But an even exponent, when you bring it to the outside, it should be absolute value. Jensen.
Do you pull out for the b to the 4th? What do you pull out? B to the 2nd times b to the 2nd?
So you can either, I mean, there's a couple different ways to look at it. You could break this down into b to the 2nd and b to the 2nd, and then b and b and b and b. So there's 2, one goes to the outside, another 2, another one goes to the outside, like that.
Yeah.
Or you could actually, with an exponent on a variable, you can take the index that's on the outside and divide it into the exponent and do it that way.
Okay.
So it'd be 4 divided by 2, which is 2.
Thank you.
You're welcome. Got like, so you're good on the 25 and the 3. There's 3 r's here. R squared, R, right? So I need 2 to go to the outside. I'm going to cancel 2 of them, bring it to the outside, but then there's still 1 left underneath. You can also use that trick that I was just saying, though. If the index is 2, I can do 2 into 3. It goes 1 whole time, so 1 r goes to the outside, and 1 remainder, that would stay underneath. So like if it was square root of r to the 7th, let's say, I would take the 2 that's out here, divide it into the 7. It goes 3 times, 3 whole times, right? So r to the 3rd goes to the outside. 1 left over would stay underneath. Or you just do 7 r's and cancel them out in its pairs. Okay. All right, 15 is 22. 16 is 1. 17 is square root 6 over 3. 18 is 6 root 5 over 5. 19 is 56. 20 is 5 minus 2 root 5. 21, negative 216 root 6. Sorry, root 3.
Where does
Jensen.
the square root of 64 come from?
Square on 19. So again, this is like Miss Ferrier's work. She breaks it down. She tries to find a perfect square and then break it down that way. You don't have to do it that way. So like 320, I would say, what did you start breaking it down with?
I didn't even.
Okay, so I would say 2 goes into that. I know it's even, right? So 2 goes into that, and it'd be 160 times.
Okay.
And then you keep going.
Okay.
2 goes into that, 80 times. 2 goes into that, 40 times. 2 goes into that, 20 times. 2, 10, 2, 5. Now let's count all our 2s. Each pair, 1 goes to the outside. So I get 2, 1's going to the outside. Another 2, another one's going to the outside. A third one, I'm bringing out that third 2, and the 5 stays underneath. So 14 times 2 is 28, times 2 is 56, times 2 is 112. And then we can cross out the root 5s, and 2 goes into this. 60, wait, that's wrong. Did I do that right? 56 times, yeah.
Thank you.
You're welcome. I would say sometimes it's easy to spot a perfect square, so it's an easy way to do that. But if it's not easy to spot a perfect square, use your factor tree.
Okay.
Yep.
Thank you. Could you go over 17?
Mm-hmm. All right, so tell me how'd you start it?
I multiplied them, so I don't
So 3 and 8, like 24,
Yeah.
over 4 and 9, 36.
Yeah,
Then you split it, or do you simplify it?
I simplified.
Okay, so this, like 12, goes into both?
Yeah.
So 2/3.
Yeah, that's what I got.
So then I'd get square root 2 over square root 3, and then you have to rationalize. So I'd have to multiply by square root 3 and square root 3, and I'd get square root 6 over 3. So a completely different way to get there, but you could do it that way. I would say if you can spot a perfect square, save yourself some work. Like the bottoms were both perfect squares. You could have also worked with that.
Okay. Thank you.
You're welcome. All right, 22, 12ab. 23 negative x squared y squared, and then the square root of xy. Actually, that's not y squared, right? That's just y. Oh, no, it is y squared. So it looks like that's the index, but it's on the exponent. 24m squared plus 6 root m. 25, 20x. 26, 13 root 5. 27, 8 root 5. 28, negative 7 root 6. Jensen.
For 25, when you FOIL it, how do you get rid of because they're both positive, the 2 times the square root of 5x?
So you can either, like she wrote this out, she literally duplicated like 2 square root 5 times 2 square root 5, right? And then I would multiply 2 times 2 to get the 4. And then square root 5x times square root 5x is square root 5x is just what's underneath, which would be 5x. Actually should be absolute value of x. So I don't think she's going to take credit. No, because there's no plus or minus in there. The other thing you could do is literally distribute this to this. So I could say 2 squared and then the square root of 5x squared, 4, and then that square root 5 squared is 5, and then x squared. So however your brain sees that is fine. It's just so if there was a plus in between, if it was 2 plus square root 5x, now I'm foiling.
Okay, thank you.
You're welcome. Yeah.
For 27, how'd you get 5 under the
So 4, you mean from this one?
Yeah.
Yeah, okay, so 80 is 2 and 40, 2 and 20, 2 and 10, 2 and 5. That's one pair of 2 is going to come to the outside, and then a second pair of 2 is going to come to the outside, and 5 is left underneath. So 5 times 2 is 10, times 2 is 20, square root 5 minus 12 square root 5. Which is that 8 square root 5? 22? 23. Okay. So first thing I would say is I can multiply the outsides together, like negative x and a positive y gives me negative xy. And then I want to work with the square roots. Because these are both square roots, I can multiply them together. So I get square root of, and it's an x squared, and a y, and an x, and a y squared. You with me so far? So I can multiply them and add the exponents, but I'm going to end up breaking them down again anyways, so you don't even have to waste that step. This is x times x, right? This is y times y, and then I've got this x and this y are still part of it. So now when I cancel, These two can come to the outside as an x. These two can come to the outside as a y. And then I still have this y and this x left underneath. So now I've got negative x times x, which is negative x squared, y squared, square root of xy. Yep. 22. Okay, so I want to multiply the coefficients first. 4 times 3 is 12, and then the square roots. So you can do this as a squared times b. Multiply the b's to get b squared, but you don't need to because you're just going to break them down again. So now I want to just break apart the a's, right? There's two a's, so 1 comes to the outside. And there's two b's, so 1 comes to the outside. And I get 12ab. All right, I think this is the last page, or is there still one more? One more after this. Okay. Ooh. 29, 12 root 7 minus root 14. 30, negative 21. 31, 11 plus 4 root 7. 32, 33 minus 4 root 15. Questions on any of those? Yeah. Yep. 32. All right, so we're going to expand this, right? Because it's a squared, I'm going to square root 13 minus 2 square root 5, square root 13 minus 2 root 5. Then I got to FOIL it. So I go first, root 13 times root 13 is 13. Outer, root 13 minus 2 root 5 would be a negative 2 root 65. Inner, negative 2 square root 65. And last, positive 4 root 5 times root 5, so just 5. So this becomes 20. And then I can do 13 plus 20, which is 33. And then these both have root 65, so minus 4 square root 65. Now you can test that 65 to see if you can break it down, but we know it's 5 and 13 because that's what we multiplied to get it. Neither of those repeat, and they're both prime. So my answer can stay just the way it is. 30. Wait, hang on. Oh, it looks like a 15, but it's 65. Okay, I was like, her answer looks different, but that's a 6. Sorry, which one? 30? Yeah. Okay, so this one we're going to FOIL out, right? So, but root 15 times root 15 is 15. Root 15 times negative 6 is minus 6 root 15. Positive 6 and root 15 is plus 6 root 15. And last is negative 36. So these cancel, and you get 15 minus that 36, which is negative 21. So the rule is, and that's kind of like a shortcut that she uses, if it's the same exact expression, but in between them is the opposite sign, so one's a plus and one's a minus, that the middle two terms are always going to cancel out. So you can actually just square the first term and square the second term and subtract them. But if you're not ready for that shortcut, then don't use it yet, okay? Work on the FOILing. When we get further, we'll do that a little bit more, but it's going to happen like every denominator we rationalize, that happens. Okay, I don't remember where I left off. 33, 2 minus root 3, 34, root 7 plus 3 over negative 2, or you can change the signs in the numerator and keep the 2 positive, so negative root 7 minus 3 over 2. 35, 17 plus 7 root 5 over 4. Questions on those? Okay, so it's the same kind of problem, right? I've got a sum with a radical in the denominator. So I'm going to take that 4 plus root 5 over 3 minus root 5, and I'm going to multiply both the top and the bottom by the opposite of the bottom. I go first, which is 12. Outer, positive 4 root 5. Inner, positive 3 root 5. Last, positive 5. This time, I can simplify the numbers, the constants, and the radical because they're both root 5. So 12 plus 5 gives me 17. And then a positive 4 root 5 and a positive 3 root 5 is positive 7 root 5. So that's my numerator. This time I can simplify it, right? The denominator, let's see if we can use the shortcut. We take the first term, we square it. We take the second term, we square it, and we put a minus between them. So it'd be 9 minus 5, which is 4. Four doesn't go into 17 or 7, so it stays just the way it is.
Do 17 plus 2 root 5?
So if it's like this, right, and only goes into part of it, you can either leave it or you can split it and simplify. Okay. You can't go, this one goes in here, but leave out the 17. You can't keep it together and simplify it unless it goes into all three parts. So if it was like 16 plus 8 root 5, let's say it was that, 16 plus 8 root 5 over 4, that, I would say this goes in 4 times and 2 times, and I'd get 4 plus 2 root 5. The one that was this one, again, you can't do this. Like, I can't cross that out. I can split it and then simplify it, which standardized tests love to do stuff like that, and it would look like that. Or you can just leave it as one fraction, unsimplify that little part, and it's fine. Yeah, you're welcome. Okay, last one. You're welcome. So root 15 minus root 5 minus 2 root 3 plus 2 all over 2. It doesn't get simplified, gets left exactly as it is. Yep. So the bottom, remember we can't keep a square root in the bottom. If it was just root 3, I'd multiply by root 3 and the top and the bottom, I'd be done. But this one is a plus or minus in the denominator, which means I'm going to multiply both the top and the bottom by the opposite sign. So I'd get, I'm going to rewrite this down here, over square root 3 plus 1. I'm going to multiply both the top and the bottom by root 3 minus 1. Now, if it was just a single term in the numerator, I'd distribute. But this is a binomial and a binomial, which means I have to FOIL the numerator. So I'm going to multiply first root 5 times root 3, which is root 15. Outer root 5 times negative 1 is negative root 5. Inner, negative 2 times root 3, which is minus 2 root 3. And last, negative 2 times negative 1, which is a positive 1. Positive 2. I would look to see if any of that can be combined. You've got root 15, which breaks down to 3 and 5. Nothing repeats. You've got root 5, you've got root 2, and then you've got a number that doesn't even have a root. So none of that can get combined. It's all going to stay as it is. Now, the denominator, you can FOIL root 3 times root 3, which is 3. Root 3 times negative 1, negative root 3. 1 times root 3, positive root 3. And 1 times negative 1, negative 1. 3 minus 1 is 2. Negative 3, negative root 3 and positive root 3 are going to cancel, so this whole thing goes over 2. But there's that shortcut you can use, right? So these are opposites. They are the exact same expression, but one has a plus and one has a minus. So the shortcut here is square the first one, subtract from it the square of the second one. Square of square root 3 is 3, square of 1 is 1, and I can get 2, which is my denominator. Again, if you're not going to remember, like if that throws you, if you don't remember it, just stick to the FOILing. But it is a shortcut that's going to happen. Every time you rationalize a denominator and you multiply it by its opposite, you can do that.
At the top, you can't like subtract the 15 and back to get radical 10.
Nope. You can only subtract and add radicals if they're the exact same number underneath.
Can you also do number 35?
Mm-hmm. Everything today, I feel like it covers all of P2, which is like everything we've started with, P2A, B, and C. There is a review on Canvas already that hopefully you started yesterday with the solutions, okay, right? I posted solutions? Yeah, okay. I'm like, I know I did them. Did I post them? Yes, okay. This is an extra one, so I'm going to add this onto it. If you feel like you need it, do it. If you feel like you're confident and you're ready, that's okay too, all right? So this I'm going to add directly onto, so this is, we're going to call this the extra one. We're going to add this directly on to the assignment. So the beginning of this is all the radical stuff that we kind of just talked about. Like we kind of covered a little bit. I feel like you should be okay enough to practice it, okay? And then I'll post the solutions to this worked out as well. If you have questions, this is your opportunity, like, let me know. So let me know what you need. If you started your quiz review yesterday and you find you have questions, that's a great thing to ask.
How many questions in quiz?
Holy crap, that's right. If there's anything on here. Today, I think based on what we